Right folks, the question we're going to do here today is a question on surface developments and a little bit on orthographic, and it has a lot to do with interpenetration of solids. So what we have here is a cube and we have a cylinder that is penetrating into it, and it says the above graphic shows an air vent pipe consisting of a cylindrical pipe which intersects a square base duct. Complete the given projections and draw the surface development of the cylindrical pipe. So what we have to do first of all is we are given the elevation, well, a partially completed elevation, a completed plan, and we have to construct an end view and then complete the elevation in full before we get onto the surface development of the cylindrical pipe. Okay, so I'm going to pan out to that now and we will start on the orthographic section. Right folks, as stated, we have the partially completed elevation here of the pipe section and we have the fully completed plan over here. And basically what it's showing us in plan is we're showing the cylindrical section here on the right hand side where the pipe is starting to intersect into the cube part, and we can see the cube part up here where the sides are going up, and we have the pipe work here. Now obviously we can see the pipe work hasn't been completed in the elevation, so that's what we're actually going to have to do. And to be able to do that, we need to actually see the pipe as a true shape. And we know when we're looking at the pipe as a true shape, or a cylinder in this case, we are going to see a circle. And in what view will we see a circle? Well, we're going to look at it from this side here, and when we look at it from this side here, we're going to project an end elevation over here. So normal orthographic at this stage, what we're going to do is we're going to create an end elevation over here, and we're going to get a circle with our cube section, and we're going to split up that circle to be able to generate the points inside here and complete them, obviously using the plan as well. So I'm actually going to start that now. We should have no problem completing the end elevation anyway. End elevation done there, guys. So we can see the cylindrical section here that is intersecting it. I put in hidden detail here at the back because this back edge is still there. We just don't see it obviously when we're looking at this view, so it's in hidden detail there. And obviously we can see this side of it here is this edge, this side of it here is this edge, and so on. Now what we need to do is we need to break up our cylindrical section into 12 segments and transfer them around so that we're going to be able to complete the elevation here. So 30, 60 degrees, away we go. So as we can see here, guys, my accuracy was a little bit out, but however this point here should have been 0.7. It's just obviously using pens, it can get a little bit inaccurate at times, but it's still going to continue on. And now what we're going to do is we're going to locate the points. Now we can actually see here, if we look at the plan view, this is where the face of the cylinder is going to intersect all along these points here. So if we actually take this point here starting off, that's one of the intersecting points. And that one there is going to be 0.1 up here and 0.7 down here. So if I actually just label them straight away, if I followed it, 1 and 7 were to come down, they're going to hit there and there. So that's 1 and 7 there. So if I had 1 up top and 7 below. Then I've got 1 up top and 7 here. Very simple. Okay? And now what we want to find is 2, 3, 4, 5, 6, 7, 8. Now, if I wanted to find 2 and 3, or let's just say 2 and 6, or 2 here for this example. So there's 2. It's going to come down where 6 is as well. That's exactly where it's going to hit there. So I'll label that. So I got 2 on top and 6 below. And it will be the exact same with 3 and 5. Three on top, 5 below, and we obviously got 4 on the outside. Now that's just half of it there, but just to explain it anyway. So, we already figured out 1 and 7, so we got to find 2 and 6. So 2 is up here, 6 is below it. And then we got to find 3 and 5. And we've got to find number 4 as well. There we go. Now, what we have found there is point number 2, which is here. Point number 3, which is here. Point number 4, which is here, because they correspond with the points over here. Got to find point number 5. Got to find point number 6. And there we go. And that is the question basically completed for the elevation, the end elevation and the plan before we do the surface development. Now, draw these in. It's a cylinder intersecting. It's going to go in like that. And excuse my inaccuracy. There we go. Now, that will be the exact same on the opposite side. So instead of having to obviously locate those points on the opposite side, I know 2 is with number 12. So if I wanted to label it, I could. 12, 11, 10, 9, 8, and so on, 7. And it'd be the same down here. Those points, depending on my accuracy, they should match up along this side here, if that makes sense. I'll actually just transfer them down. Not to check, but just have everything neat and tidy and in order. And at this point here, they should come across and across. They would match up. So it's the same thing. So 1, 2, 3, 4, 5, 6, 7. On the outside, we had point number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. All matching up. And that is the elevation and plan fully complete. Just heavy in this line here as well. There to there. Okay. Now, in completing the final part of this question, which is surface development of the cylindrical section here at the front of it. So what we have to do is we have to develop this out. So once again, what we're actually going to do is, when we develop out a cylinder, it all comes down to the actual generators. And we can see along here that we have a series of generators running along it that all actually have true lengths attained to them. And the reason we know they are true lengths is because they are parallel with the XY line. And if you could actually look down here, those generators that are up here are down here as well. And I'll actually highlight a couple of them in a different colour here now in a second, just to give you the idea. So, if we take the generators coming from, let's say, 3 and 11, this one here. So if I just highlight that one there. That 3 and 11 generator, right there, that is a true length. And the reason I know that's a true length is because it is the same distance number 1 in plan, And the reason any line down here or any of these generators down here are true length is because they are parallel to one of the principal planes. Now, what that means is, in plan, this line, this generator here that I'm saying in this case is number 3 and in this case is 11, so I actually should highlight this one down here because they're both the same. They are parallel to the XY line. Okay? And what that means is they have a relationship whereby they will never touch each other. And any line that is parallel in one view, that means that it is a true length in the other. So in this case, this is a true length up here, and because it's the same distance down below, in this case, they both actually happen to be true lengths. And now what that means is every generator along here, be it 1 all the way up to 12, that means every one of them is a true length. So what we can do is, to complete the surface development of that, like any time with cylinders, we are going to roll it out and pick a start point, and usually I start with number 1 as my start point. So if I took right there, looking at this, I'm going to take that point there as number 1. And in my end elevation, which is this view over here, I'm going to take this distance here between my segments, and I have 12 of them. I'm going to step it off 12 times. Anytime we have a cylinder, we're going to roll it out based on how many sections we have or how many cuts. So, step it out 12 times. So, if that's 1, there's 2, and so on. 11, 12, and we always get back to 1 as well. Close it off. So, if I take my 1 and my 7, because they have the exact same lengths, what I'll do is I will transfer them up. And where 1, which is here, and 7, which is here, and 1, which is also up here, straight away there I can heavy in a certain part of it. So I can heavy out as far as the 1 here, heavy up all along this side because that is where the circle at the very front of it is. And I will also heavy in the 1 because that's where it's going to close on the outside. And as I said, we found a point also number 7. Now it's a case of finding 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. And as I said, they're all true lengths. So every one of these I'm just going to step out now. Okay, so 2, 12, 6 and 8 are all on this line. So 2, which is there, 6 is another one, all the way up to 12, so I'm going to need all 4 of them. And while I'm at it, I'll just locate them. So I said 2, 12, 6 and 8. The exact same with 5, 9, 3 and 11. So 5, 9, 3 should have been extended out just a touch further, so right there, 3 and 11, and then the very last one will be 4 and 10. And we have located all our points now. There's 4 and there's 10. And at this point we know what to do. It is just freehand sketch. And there we go. That is the surface development of the question done along with the completed elevation and end elevation. Question complete.